Natural selection is the topic of the day. And natural selection can easily be summed up by this quote by Charles Darwin, in which says, "It is not the strongest of the species that survives, nor the most intelligent that survives. It is the one that is most adapted to change." And that change is what natural selection is all about. How do organisms change to fit their environment and to survive and pass on their good traits that are in or meant for that environment? And this is the definition that we're going to use in class for natural selection. Organisms that are better adapted for the environment will survive, and not only survive, they will thrive, producing offspring with the same desirable traits. The good traits, the ones that help the parent organism survive in that whatever environment it is, will be passed on to the offspring to give them the best opportunity to survive in that environment. Let me give you a little example of how natural selection works. These are peppered moths. They are both the same species. 98% of peppered moths look like this, and you can see where they get that peppered name. They look like they have a little pepper put on them. And this is the same peppered moth, except it has a genetic trait that gives it this dark black color. In the early 1800s, peppered moths look like this. You can see how well adapted this peppered moth is on the tree bark that hid it from predators. Whereas this peppered moth, birds could easily see this one on a tree, and then this one became lunch or dinner. 98% of peppered moths in the early 1800s look like this. Only 2% look like this. However, when the Industrial Revolution came around and there were factories and plants putting out a lot of soot and pollution in the air, the trees in the surrounding areas ended up getting covered with this black soot. And you can see how these trees got covered with this soot, and then guess what happened? That's right. These peppered moths were reproducing, and they had a population explosion because predators, birds, were able to see these peppered moths better. So these peppered moths ended up declining, whereas these peppered moths ended up, their population started exploding. That is a good example of how natural selection works. These peppered moths were adapted for the new environment that was created, whereas these ones weren't. So these ones thrived and these ones didn't. Scientists are able to use evidence from the past to help them build what animals look like and how they adapted over time. For example, here is our typical whale that we know of today. But in the past, as we go back through the fossil record, we can see that the whale's ancestor once lived on land. So let's take a look at some animations of how scientists think that the animal went from a land-dwelling animal to a whale that is simply aquatic all the time. These majestic creatures once used to live on land. How did we get to the ocean? Let me show you. Here's the whale's common ancestor at 48 million years ago. Finding food in streams and in shallow water, legs are for walking on land. At 47 million years ago, finding food still mainly in the water, legs have become more adept at swimming. The nostril is starting to move further back on the head. At 46 million years ago, the whale's ancestor is more sea lion-like, living on both land and in water. Limbs are mainly for swimming only. The hind limbs are starting to disappear, and the nostrils are still further back on the head, like the blowhole in the whale that we see now. At 37 million years ago, the whale's ancestor is completely aquatic at this point. Nostrils are definitely a blowhole on the top of the head, and the tail disappears, becoming the fin you know at the back of the whale today, known as the fluke. Today's whales come from a common ancestor that once lived on land and walked there. How do we know this? Where's the evidence of these creatures once living on land? Those are great questions, so let's find that evidence. So the fossil record is one piece of evidence that scientists use to track how animals have adapted over time. There is other evidence as well. The evidence that scientists use to show that natural selection takes place. We've talked about one already, and that is fossil evidence. The second one that you can place in your chart is called DNA evidence, the newest type of evidence that scientists have at their disposal. A third one is embryonic evidence. A fourth one is vestigial structures. And then finally, we have homologous structures. These five pieces of evidence help scientists trace how animals have adapted over time. You will place those five pieces of evidence on your chart. Now we're going to get a definition for it, and you're going to place a picture, any picture that you can find, that'll help remind you of what kind of evidence we're talking about. Let's first talk about that fossil evidence. Scientists discover fossils buried in layers of the Earth's crust, and they tell a story about what creatures lived on Earth and how they lived during different times. For example, let's zoom in on the fossil of horses. So up top you have your horse of today. You can see the different kind of hooves that it has. Its head looks like it's much larger, and its body is much larger than it was. Let's go back to early times where, look at the hooves or the feet of those horses. They look like almost chicken feet. I wonder why they look like that. And that's what scientists do. They question. For example, maybe the terrain was what caused the feet to be that way. And as the terrain changed for horses, the hooves eventually changed to what we know today. The head or the jaw now looks a lot more larger, like it's meant for grinding vegetation, what horses eat now, as opposed to what the jaw looked like back then. The vegetation and what the horse ate changed the horse's jaws. What you can place in your chart is this information right here. By dating and organizing the fossils, scientists can use their slight differences to create a timeline for the evolution of a species. DNA and genetic evidence is the newest form of evidence that scientists have at their disposal to use. Scientists can now compare the genes of several species and determine how similar they are to one another by decoding their genetic code. Please place that in your chart. Our third type of evidence is embryonic evidence. I find this embryonic evidence to be so interesting. Let's take a look at the embryonic evidence. Look at the embryos of fish, salamanders, turtles, chickens, rabbits, and humans. Now, these are very early on during the process of embryos forming, and you can see how similar all of those are. One of the reasons that they could be similar is that they are all animals. And then as we get a little bit further along, you can see that the fish and salamander continue to still look like one another, but the turtle, chicken, rabbit, and human look familiar to each other and not so much a fish or salamander. As we keep going, look how similar the rabbit is to the human. Even the turtle and chicken still look a little bit similar. So this is how scientists use embryonic evidence. Embryonic evidence is found by comparing the embryos of living things before they are born. Vestigial structures is our fourth piece of evidence, and they are body parts or structures that are left over from a long time ago, from an ancestor and it's no longer useful to the current species. So take a look at our whale. We've seen some animation. Why would a whale have a femur bone, that long bone from your hip to your knee that you have? Why does a whale have one? Why do they have a pelvis? Well, it's because, and we saw the animation where the whale used to once live on land and had 4 legs. You, for example, have a bunch of vestigial structures. You have an appendix. Your appendix is not needed any longer. your sinus cavities in your face, not needed any longer. So vestigial structures are body parts or structures that are left over from a long ago ancestor that are no longer useful to the current species. Our fifth and final piece of evidence are homologous structures, and these homologous bone structures are found by comparing the bones of similar species. So if you look at the human, cat, whale, and bat arm, wing, flipper, they all have these same exact bones, just in different types of sizes and orientations, but they all have the same ones. I wonder why that is. And then scientists look back and they are able to compare, thinking, okay, humans, cats, whales, and bats are all, what are they? They're all mammals. So it does make sense that they all have these similar types of bone structures. And who do we have to thank for this? That's right, our buddy Charles Darwin. In 1931, he went on that 5-year voyage on the HMS Beagle, and his job was to go around, and they spent time, the British did, mapping the coastline of all these different countries so that they could see where their boats could either port or they could build some sort of fort along the coastlines of these different countries. While doing that, they spent 5 weeks in the Galapagos Islands, and that's where Charles Darwin started his ideas of how natural selection takes place and what it means for all these different species. He studied a lot of different animals, and one of the ones he studied the most were these finches. He noticed that these finches all belonged to the same family. However, they had different shaped beaks depending on the type of food that they found there. It took Darwin about 20 years to publish his work. One of the reasons it took so long is that natural selection definitely would have been frowned upon back in those days, where the church had a lot of influence. By Darwin saying that natural selection took place over time, it would have went against some of the teachings of the church in the Bible at that time, and he could have been punished, because some people were, back in the early 1800s, punished for their thoughts that went against the church. He had 5 steps of natural selection, and we're going to talk about those now. His steps of natural selection that you can place in your chart are overproduction, variation, struggle to survive, survival of the fittest, and inheritance of traits. Let's break down each one of those and talk about what each one is. So our first step in natural selection that Darwin came up with was overproduction. Overproduction is organisms produce an abundance of offspring, and only some will survive to adulthood. A great example of this is, we'll take what turtles do, especially sea turtles, when they come up on the sand and they dig a hole and they lay hundreds and hundreds of eggs into a hole, knowing full well that only some of their offspring will go on to survive to adulthood, and it's going to depend on the different traits that they have. The second step is variation, and variation means a variety of different traits. Although the offspring are the same species and they came from the same parent, they're all a little bit genetically different, and they have different traits. Some are helpful and some are not. So for example, if the sea turtle laid eggs really far up the beach, and it would take the baby turtles a long time to get to the water to be safe, well, then larger fins might help those sea turtle babies get to the water faster, whereas smaller fins may not. And then we have the struggle to survive. And for all species, there are hazards that may cause them not to survive to adulthood. And that's a lot of different things. Disease, predation, predators are a big one. Weather conditions, maybe there was a drought, or maybe there was a flood or tsunami or some sort of weather condition that caused problems for those offspring. Food sources, either being too available or not available enough, may cause problems. Competition for resources, maybe that the space where these turtles live, there's not enough. So some of them are going to die off because they can't get the food that they want. So essentially, there's a struggle in the environment for the sea turtles to survive. And then we get to survival of the fittest. Those who have the best traits or adaptations for survival in their environment are going to be successful and live to adulthood. So in those conditions, those traits and adaptations could change from year to year as the sea turtles lay eggs. Maybe the sea turtle didn't lay the eggs as far away one year as they did another, and certain traits that the baby sea turtles had were better suited for where those eggs were laying. Then finally, we have the inheritance of traits. The creatures that were able to survive to adulthood, they are now going to reproduce, and they're going to pass on the genes for those good qualities that they had that helped them survive to their own offspring. So the inheritance of traits is our next one. And you can put that in your chart. That brings us to the end of our introduction into natural selection and the steps of natural selection. Be sure to fill out the definition of natural selection, and then make sure you have your 5 pieces of evidence, the definitions of those, place a picture in that'll help remind you. You can easily find the pictures I had in the videos to fit your notes as well. And then the 5 stages of, or 5 steps of natural selection, make sure you have those listed in there as well as the definitions for those. And we'll be using those in a couple lessons coming up here soon.